is Dilip Chakravarthy, Assistant Professor in Cybersecurity Department in Institute of Aeronautical Engineering. Today we are going to discuss about data warehousing and data mining. So we'll see the first concept of introduction to data warehousing. Before going to see about the introduction to data warehousing, let us see what are the contents that are there in data warehousing and data mining. If you observe, this data warehousing and data mining, it is divided, it has given as 5 modules. We'll start with what is data warehousing. Then we'll discuss about the data mining. So what do you mean by data warehousing? We all know that data warehousing, we all know warehousing. Warehousing is nothing but where we store a huge amount of anything. So suppose warehouses are used to store rice, paddy, something like this. Similarly, here we are going to store a huge amount of data. That's why we used to call it as data warehouse. Okay, so we'll be knowing about data warehousing here. What do you mean by data warehousing, and how you are going to represent the data warehousing. So we are going to use some models here. Okay, so like database management system, there you will be using ER model, relational model, and hierarchical model. Similarly, here we will be using some multi-dimensional model. So where we are going to represent our data in the form of data cubes. So data cubes, where what is this data cube? So data cube, in that we'll be considering about fact tables, we'll be considering about dimensions. So in DBMS, we will be concentrating mainly only on 2 dimensions, but whereas in data warehouse, we need to concentrate more on different, many number of dimensions. That's why we used to call it as a multi-dimension. Okay, so here we'll be using dimension tables and fact tables. So all combining together, we'll call it as data cubes. Okay. So for representing our multi-dimensional model, so we are having some schemas. We'll be using some schemas such as star schema, snowflake schema, and fact constellation. So we'll be discussing about all these things clearly in the later sections, and we'll see about the measures. So how you are going to measure? Measures are nothing but the values. So how are my values? For example, if you are talking about the sales, so sales of any product, so you'll be saying it in regarding some dollars or regarding some numerical values. We'll be saying it as measures, and then we'll discuss about concept hierarchies. So we know hierarchy is nothing but where we will be representing our data in level by level fashion. Okay, here we are going to represent our concepts in a hierarchy. So for example, if you take a location, suppose if you want to analyze the sales regarding considering some location, so if I consider it as country, so in that country, how is my sales? So in the particular country, so there may be many number of states. Okay, in the particular state there may be many number of districts. So in the particular district there may be many number of towns or cities. Like this way, I am going to divide my location. I am going to arrange my location. We call it as concept hierarchies. Okay, so after discussing about this concept hierarchies, we are going to know about data warehouse architecture. We'll be using some architecture for building our data warehouse. We'll be using some 3-tier architecture where we'll be learning what is there in top layer, what is there in middle layer, what is there in bottom layer. So from where we are going to get the data. We'll be discussing all about these things such as types of servers. So we are having different servers, relational OLAP, ROLAP, MOLAP. We'll be considering all these things as servers. From those, we are going to get the data. Okay. So finally, we are going to know about data warehouse implementation. Okay. After knowing about the architecture, we are going to see how it is going to implement, how the data warehouse is going to implement. Okay, so then we'll be discussing about data marts. So what do you mean by data mart? Data warehouse is nothing but where we are going to store a huge amount of data from different sources. But if you are considering only particularly one subject, we say it as data mart. Okay, so we'll see what do you mean by data mart. And finally, we conclude with differences between OLAT and OLTP. So online analytical processing, analytical transactions, and online transaction processing. Okay, OLAP and OLTP. Okay, so these are the things we are going to discuss in the first module of our data warehousing and data mining. From second unit, we are going to learn about data mining. So what is this data mining? So we generally hear the word mining. Mining is nothing but extracting the thing. So we used to hear sand mining or gold mining. We are going to mine, or we are going to extract gold from the rock. Similarly, here we are going to extract knowledge from the data, from the given data. As there is the huge amount of data. From that, we are going to extract some knowledge or information. So we used to call it as data mining. Instead, we need to call it as knowledge mining. But as people are familiar with this word, they named it as data mining. Okay, and what are the steps that are involved in data mining? So, in extracting the knowledge from huge amount of data, we used to undergo different steps. There are some seven steps. We used to call it as a knowledge discovery in data. It's a KDD process. Okay, for extracting the data. So, how we are going to extract? Okay, maybe I'm applying some transformation tools. I'm extracting. I'm transformating, I'm loading. Okay, I'm doing something with my data, and I'm going to extract my knowledge. Okay, so then we'll discuss about kinds of databases. So on what data I'm going to mine. Okay, so I'm going to extract my data. From where I'm going to extract? So maybe I'm going to extract from databases, data warehouse, or maybe from internet, world wide web, or maybe from multimedia things. Maybe I'm talking about spatial data. So there are different types of data. Okay, so we'll be using different types of data. From that data, we are going to extract uh, the knowledge. Okay, that is about kinds of data. We'll be studying about that, and then data mining functionalities. See how my data mining is going to function. So maybe I require my data in some way. So maybe the other person require the data in some way. So here we used to know about different data mining functionalities, such as mining frequent item sets, and classification and prediction. So outlier analysis, evolutionary analysis, clustering. So these are all the different data mining functionalities. We'll see all one by one. So which are very very important, and which are very useful in extracting the data. Okay. Followed by this data mining functionalities, they said about the classification of data mining systems. So how they have classified the data mining system. So data, you'll say like this: data mining, it's a confluence of different disciplines. So it may be statistics, it may be machine learning, it may be related to some other application. Okay, see, we are combining all those concepts, and we are making it as a data mining. Okay, so data mining, it has classified into different types. So maybe on the kind of data, maybe on the kind of technology, maybe on the kind of functionality, maybe on the kind of application adapted. Okay, in this way we are going to classify my data mining system. Okay, then data mining task primitives. what are the tasks of data mining. So what are the basic things in data mining we'll be seeing here before going to mine the thing. So we used to undergo several steps how we are going to extract my knowledge. So such as the first task he has given is finding the relevant data. So we need to know on which type of data I need to extract my knowledge. Maybe suppose if I take a medical analysis, if I am performing medical analysis, at the time I need the data related to medical things. I'm concentrating only on medical things. Okay. Then second task he used to say it as what is the functionality I'm going to apply uh, on my data, whatever I have taken. Maybe I may be using mining frequent item sets. Maybe I'm using clustering. Maybe I'm using outlier analysis. Maybe I'm using classification prediction. Any one of these things I may use it, and I'm going to mine. Okay, then what are the interest things that are there in my subject. So after knowing about the background, so in thought print you will say it as knowing about the background knowledge of the domain. And fourthly, you'll say we'll be finding the uninterestedness things and the interestedness things. And finally, how we are going to visualize this data mining. We'll be seeing all those things as data mining task primitives. Okay, so this is about the basic thing of data mining. Then before he said about data pre-processing. Before extracting the exact information what we require, first we need to pre-process the data. What do you mean by pre-processing? We'll be learning about this pre-processing. So before processing my data, so what are the steps we are going to do? So we are going to do some steps such as data cleaning, data integration and transformation, data reduction, data discretization and concept hierarchy. All these things we are going to perform before processing my data. Okay, so each and every step is having some methods how to clean my data. So such as we'll be using some binning methods. We'll be finding, so when we are going to clean the data, so maybe I may come across missing values, maybe I may come across noisy data, maybe I may come across inconsistent data. So at the time, how I am going to handle such type of data. So there I'll be learning about this data cleaning. After doing all those things, then I'll say I'll be collecting data from various sources. So all the information I collected, it should be integrated. Okay, so we say it as data integration. So after integrating the all the data, then I need to make it into one format. I need to make it into one format. We say it as data transformation. Okay, so then he talks about data reduction. So if the data is huge, so I need to reduce the volume of data. So we call it as data reduction. We'll be using some data reduction techniques, and we'll reduce the data. And finally, we see about data discretization and concept hierarchies. So here in data discretization, if the data is numerical value, if it is a continuous variable, so then how we are going to discretize that data? So we'll be applying some methods, and we'll be discretizing our data. Okay, this is about module 2. Then we'll be seeing about association rule mining. So in the module 3, module 4 and module 5, we'll be discussing about various functionalities of data mining. Okay, such as association rule mining in the third module. In the fourth module, I said about classification and prediction. And in the fifth module, he said about clustering. So coming to the third module, how I am going to implement this association rule mining. There are various algorithms such as a priori analysis, frequent pattern growth algorithms. We will be using these algorithms for finding frequent item sets. Okay, so by using these techniques, we'll be finding the frequent item sets or frequent substructures or frequent subsequences. We'll be knowing about all these things. In the fourth module, we'll be discussing about classification and prediction. Here, we are going to classify the data. So, how we are going to classify the data? For example, suppose if you want to predict about the fall of rain, so whether there is a rain in next hour or whether there is a rain tomorrow. So for that, I need to have the data. So for example, let us take, I need to know the humidity value, I need to know the temperature value, I need to know the outlook, how is the outlook presently, so whether it is sunny, whether it is cloudy. So based on these values, I'm going to predict whether there is a fall of rain or not. Okay, so based on the values, whatever I'm saying, we consider it as classification. We are classifying whether there is a fall of rain or not. Okay, we'll be considering some class variables, class labels, yes or no, something like this, based on the data whatever we are having. So we'll be predicting the value. Okay, so we'll be using some different algorithms here, such as Bayesian classification. So we'll see that Bayesian classification and classification by decision tree induction. We'll be using some decision tree and classification based on concepts from association rule mining and other classification methods. So we'll be learning about all these things in the module 4. Okay, so then coming to module 5, here we'll be learning about the data mining functionality, clustering. So how you are making the data, how you are grouping the data. So we know there are two types of learning. One is supervised learning and another one is unsupervised learning. In supervised learning, we'll be having some class labels. Based on that, we'll be finding the data. But whereas in unsupervised learning, we don't have any class label. Based on the similarity only, we are going to find the data. Okay, so this clustering comes under that unsupervised learning. So based on the similarity, we are making it into groups. The data is large, so in the data, we are grouping the things which are similar. Okay, for example, if you consider a shopping mall, there you will find lot of stores, such as it may be related to electronics, it may be related to food products, it may be related to dress materials. Okay, see, now whenever a load comes to that mall, so they won't say it should be placed here. Okay, based on the similarity, so the product is placed in the particular store. So if you have taken an AC, that will be placed in the electronic space only. Okay, we are not going to place it in dresses. Okay, so why? Because we are comparing, we are finding the similarity between this object and that object. We say it as clustering. Okay, there are different clustering methods we'll be learning, such as k-means partition methods, hierarchical methods, density-based methods, grid-based methods, and we will be implementing all those things. We will be seeing all those things in our fifth module. Okay, so finally we conclude with mining complex types of data. So if the data is large, if the data is complex, so how you are going to mine such type of data? For example, if you consider spatial data, if it is related to maps, information about maps or information about areas and locations, so at that time it is difficult to mine. Okay, how such type of things can be mined, how multimedia databases will be mined, all how these time series data will be mined, all these will be discussed in the fifth module. Okay, so we'll be learning and we'll be knowing about all these modules in data warehousing and mining. Okay, that's why I used to say it's a very very good subject, which is not only for students, for anybody, whoever is going to Suppose if I need to start up a new business, so at the time I require data. Okay, so I can use any one of these technique and I can get my data. Okay, anyhow we are going to see everything clearly in the coming sessions. Okay, so today we'll discuss brief about introduction to data warehouse. What is this data warehousing? A data warehousing is a collection of data marts. So data mart, what do you mean by data mart? First of all, data mart is nothing but it's a small storage. Okay, so we are storing some data. Okay, we are storing some data. So, but we are grouping all these data stores and we are making it into a data warehouse. Now, for example, suppose if you order for a fast track watch, which is if you order in Amazon, if it is in Bangalore, from there it will come to the warehouse in Hyderabad. It will comes to warehouse in Hyderabad. Here in this warehouse, so they will be storing all the items, not only watches. They will store all the things, maybe bikes, maybe electronics things, maybe food products, maybe the all the things we can see in the market. Okay, so they are storing everything there. From that warehouse it will come to our place. Okay, so what I am saying is, so a data warehouse is nothing but where we are collecting huge amount of data. Okay, here also a data warehouse is a collection of data marts representing historical data. Okay, so here I'll be finding historical data from different operations in the company. Okay, now for example, if I need to start up a company, if I need to start up a business. Okay, so before starting the business, first I will analyze how is that business, what are the incomes and what are the ins and what are the outs, what are the pros and what are the cons. We'll be seeing everything. Okay, so how we are seeing, so we'll be getting the data. So already some people have already started that business, so we'll be collecting the data from that store or from that people. That is what we call it as historical data. So by picking the historical data, so I am going to analyze my I am going to think about my business. Okay, next, you'll say this data is stored in a structured, optimized for querying and data analysis as a data warehouse. Okay, so now how we are going to store means it is in a structured format. Okay, we are maintaining a structure. So why we are maintaining a structure means we need to retrieve the data correctly. So we need to post a query on the data warehouse and we need to get the data correctly whatever I require. That's why we used to say it as a structured format. Okay, so then you'll say a data warehouse can also be viewed as a database for historical data from the functions within a company. Okay, so various peoples have given various definitions regarding data warehousing, but who started this data warehousing? Who started this name called data warehousing? The name, the term data warehousing was coined by Bill Inman. Okay, he started. He used this word first, data warehouse. So in 1990, so he defined the data warehouse in four ways. A warehouse is a subject-oriented, integrated, time-variant, non-volatile collection of data. Okay, so we will be seeing all those things. How is it? We'll see each and every part. Okay, a warehouse is a subject-oriented. Okay, what do you mean by subject oriented? Now I'm collecting the data. Okay, so I'm collecting the data related to something, related to some subject. So maybe I'm collecting the data related to student, maybe I'm collecting the data related to games, maybe I'm collecting the data related to movies. Okay, so this is subject oriented data that gives information about a particular subject instead of about a company's ongoing operations. We are not concentrating on company's ongoing operations. We are concentrating what we require. We are just concentrating on what is the thing we require. Okay. Then secondly, you said integrated. Okay. So integrated means I need to collect the data from various sources. Data that is that is gathered into the data warehouse from a variety of sources. Okay, I'm collecting the data and I'm merging the data. So suppose if I need to start up a new business, as I said, a bike showroom, if I need to start a bike showroom, so probably I'm analyzing whether I will get profits or losses. So how I'm going to analyze this? I'll be getting data from different showrooms nearby. So how are the sales there? So from let us think there are A, B, C, three stores are there nearer to my location. So I'll be getting data from all these three stores. Okay. So and I'm integrating all the data, whatever I get. Okay. I'm combining all the data. We used to say it as integrated. Okay. And then he said time variant. Time variant, all data in the data warehouse is identified with a particular time period. Okay. That is it is varied based on the time. Some data is varied based on the time. For example, if you see the sales of ACs and sales of coolers in this May and April time, it is very huge. When you compare with the duration November and December, so people they won't use they won't buy these ACs and coolers at November and December time. Okay, so data is changing. It's depending on the time. That is what he's saying. For example, the sales of watermelons, if you observe, okay, sales of raincoats. So during summer, raincoats will be sold only less when compared with rainy season. So in the rainy season, people used to buy a lot. Okay, that is nothing but, so the data is variant. So the data, whatever that is related to that one is changed by time to time. Okay, so then I say non-volatile. Data is stable in data warehouse. Whenever you store the data, so it is not changed. The data what you have stored is not changed. Even when you saved some data, you are storing the data related to students marks or students grades. Okay, you'll be storing everything. So after a year or after 10 years, if you see, the data remains constant. Okay, it is same. It has not changed. Okay, so we used to say it as non-volatile. The data is not changed. Okay, so data is stable in data warehouse. Okay, so these are the four definitions, four parts in defining the data warehouse given by Bill Inman. Okay. Okay, now let's see data warehousing can be, what the data warehousing can do. So what is the purpose of data warehousing? So data warehousing, by using this data warehousing, we can take decisions. Okay, so now for if I am a manager, if I am a head of some company, I used to take decisions. Okay, so for taking decisions, I require the data. If data is available, based on that I'm going to take the decisions. Okay, so this data warehousing, from data warehousing I'm going to collect the data and I'm going to take the decisions. Okay. So first thing I'll be using it for taking decision, and secondly used to manage and control business. So data can be data, this data warehouse is used to manage and control business. Okay, so from data warehouse I'm collecting the data and I'll be finding, so where I'm getting the losses, where I'm getting the profit, so that I'm managing my business, I'm controlling my business. So I'm seeing where what to do for minimizing my losses, what to do for maximizing my profits. Okay, then it is used by managers and end users. Data warehousing is used by managers and end users to understand the business and make judgments. Okay, so both are similar, it looks. It is used for taking decision. Okay, so we are going to analyze the business. For understanding the business and for making judgments, we'll be using this data warehouse. Okay, then data warehousing is an architectural construct of information systems. Okay, so it is an architectural construction of information system that provides users with current and historical decision support information. So it is having both current information as well as historical information. Okay, so I'll collect the data where it consists of today's information, whatever it is undergoing. Similarly, what has happened earlier. So it is nothing but historical data. All these things are used to take my decision. Okay, so decision support information that is hard to access are present in traditional operational data source. So if you compare with database, it is very difficult for taking the decisions in data warehouse in databases. But whereas if you are using data warehouse based on the data, past data and current data, you can take the decisions easily. Okay. So what are the different terms that we are going to use in this data warehouse? Means we will be learning, we'll be seeing, we'll be come across these type of terms such as enterprise data warehouse. Enterprise data warehouse is nothing but the data that is related to whole company. It collects all information about subjects like customers, products, sales, assets, personnel. All these things are related to the business. All these things are related to some one enterprise. Okay, so then data mart, as I already told you, data mart is nothing but it's a part of data warehouse, departmental subsets that focus on selected subjects. We are focusing only on selected subject. Yes, data mart is a segment of data warehouse. It is a part of data warehouse that can provide data for reporting and analysis on a section. Okay, so analysis on a section, unit, department, or operation in the company. And data marts are sometimes complete individual data warehouses, which are usually smaller than the corporate data warehouse. Okay, these are very small when compared with data warehouse. Okay, so then the word decision support system. So this data warehouse is used for decision supporting system, information technology to help the knowledge workers. Who are these knowledge workers? Maybe an executive, a manager, analyst. All makes all gets data and they are going to take better decisions. Okay. So then the word called drill down. So we are arranging the data in a hierarchical fashion. Okay. So level 1 to level 2. So level 2 to level 3. So we call it as drilling down. Drilling is we are general word is putting hole. Okay, we are going inside. Okay, so here also we are going inside the data warehouse. Okay, so we will be seeing what do you mean by drill down and metadata. So what is this word metadata? Generally, we used to hear the word metadata. Metadata is nothing but data about data. Okay, for example, if you observe the textbooks, we will find a page called contents in the start. So there they will be giving the topics and the page numbers. So the topic is there at a particular page. 20, let us take 28. In the 28 page, you will be finding this data. You are defining the data. Okay, you are telling the about some other data. So that is what he is saying. Data about data. We call it as metadata. Okay, so containing location and description of data warehouse system components, names, definitions, structures. Everything we'll be discussing. Okay, we'll be seeing that. Then, what are the benefits of data warehouse? So, we are using this data warehouse. What are the benefits? We are having a lot of benefits. These data warehouses are designed to perform well with aggregate queries. Okay, so we'll be using this data warehouse from this data. So this data can be used for end users to take decision. Okay, the structure of data warehouse is easier for end users to navigate and understand. Okay, and query against, unlike the relational databases. So we can post query on this data warehouse and we'll be getting the data. Okay, then data warehouse enables queries that cut across different segments of a company's operation. So I can know various operations that are performed in the company, what is happening. Everything can be easily noticed by using this data warehouse. Okay, so queries, whatever I'm using, queries that would be complex in very normalized databases could be easier to build and maintain in data warehouse. So whatever the queries you are using in database, those are very complex to retrieve the data. Okay, but in data warehouse we can easily retrieve the data by using a different model. Okay, data warehousing is an efficient way to manage and report on data that is from a variety of sources. Okay, so data warehousing is an efficient way to manage demand for lots of information from lots of users. Okay, so these are the different benefits. There are a lot of benefits of data warehouse. We'll be seeing a lot of things in the coming classes. You'll get a clear idea about the advantage of data warehouse and operational and informational data. So, what is this operational data? So, whatever the data that it is operating now, we call it as operational data. He has given the points there. So, focusing on transactional function. So, we are focusing on transactions. So, whatever the transactions that are running, such as bank calls, withdrawals, deposit. Okay, so such type of information we call it as operational data. So we'll be finding the detailed information there in operational data. Okay, so we'll be finding detailed information. Then we can't update the data. Already it has done. It has been completed. Okay, so we can't change the data. That's why we call it as updatable. We can change the data, not update. We can change the data. Why? As it is running, we can change the data. Okay, then reflects current data. So transactional data means, so we are talking about the current data. Okay, whereas informational data, so focusing on providing answers to problems posed by decision makers. Okay, so whoever are going to take the decisions, so they are posting some questions. Maybe suppose I need to know the sales of particular item. Okay, so I'm just posing a query to the data warehouse. It will get the data. So it will get the data which is already there. So we call it as a historical data, past data. Okay, which is in a summarized format. Then the data which is unupdatable, that means non-updatable. So we can't change it. Why? Because it has already been done. Okay, so it has already been done. Whereas in operational data, it is running. Is the transaction is in running process, so we can update it. But whereas in informational data, so we can't change the data. Okay, non-updatable we can say. Then data warehouse characteristic. What are the characteristics of data warehouse? A data warehouse can be viewed as an information system with the following attributes. We are considering some attributes for defining my data warehouse. It is a database designed for analytical tasks. This data warehouse is used for analysis purpose. Okay, analytical tasks. So for analyzing my data, before analyzing anything, we require the data, isn't it? So for that purpose, I am using this data warehouse. Its content is periodically updated. Okay, so that means every day I'm updating my information. Today I got new information, so I'm just adding that information. So in this minute I have added some other information. I'm not changing the data, just I'm updating it. I'm adding a new thing. Okay, its content is periodically updated. Then it contains current and historical data. So data warehouse contains not only current data but also historical data to provide a historical perspective of information. Okay, whereas if you talk about operational data stores, ODS is an architecture concept to support day-to-day operational decision support and contains current value data. Okay, we'll be talking about the current value data propagated from operational applications. ODS is subject oriented. Okay, ODS means operational data store, which is subject oriented, similar to classic definition of data warehouse. It is subject oriented, as we have seen the definition given by Bill Inman. So such like subject oriented. Okay. So then ODS is integrated. Operational data store is integrated. Okay. Thank you. In the next class, we'll discuss about what is multi-dimensional. Okay. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.